Here we have a problem that asks us to rotate a point and give its coordinates. So it says first rotate the figure 90 degrees counterclockwise about the origin. Then give the coordinates of the marked point in the original figure and in the final figure. So we'll go ahead and label this point a little darker so that we can see this is the point that we're concerned about. And we know that we are rotating about this origin 0, 0. Whenever we're rotating in a positive degree, it's actually in a counterclockwise direction. So we would start and we would rotate in a counterclockwise direction 90 degrees. And we're talking in terms of a circle has 360 degrees, so it would be a quarter turn of a circle. And what we're doing is, what we want to do is we want to label, kind of, you notice how this line here is thick underneath this part of the x-axis. So whichever part of the x-axis that the figure is closer to, the positive portion or the negative portion, here it's on top. We're going to draw this line in nice and thick, because what I want you to think about, just moving the line, not as much the figure moving as the line rotating. This line rotates back 90 degrees. It's going to be going backwards counterclockwise 90 degrees. So this portion of the line really just flips up and becomes the new y-axis on top here, the positive y-axis. And we'll be able to see that when I use the tracing paper. So this origin that it's rotating about, if we think about putting a pivot point right here on the origin and then taking and pushing this line here, this axis, and pushing it and rotating it, the figure would go with it. And we rotate it up to where it becomes the new positive y-axis, and then we'll see what happens to this figure. So I have my tracing paper here that I'll line up, and see how we've lined up here. Here's my figure, and this is what we want to do. We want to put our pivot point right here, and we want to rotate 90 degrees in the counterclockward direction. So as I rotate it, it's like I'm pushing this line up, and as I push it up, what happens to the figure? And then when we line it up, notice that the figure here, the figure stays constant in relation to this line. Down here, notice down here, we have just the bottom line here is only a distance of 1 unit from this axis, 1 unit from the axis, and when we rotate it up, it's still only 1 unit from this point, this axis here. It's still only 1 unit, but it just has a different look to it if we're comparing it to the overall picture. And then our new coordinate would be up here. Now there's a formula to this, and the formula looks like this. If we are rotating 90 degrees in a counterclockwise direction, then our xy coordinate becomes a negative yx, just meaning that whatever our original x was, the new value of it was the value of the old y, but now a negative. And it'll make more sense when I go ahead and draw it out. So let's see what this point is. If we come over here, we're going over 7 and up 4. So we have a value of 7, 4. 7, 4 is my x, y value. Now if I want to turn this into a negative y x value, what I would do is I would have my y here, which is a 4, and I would make it a negative. So I could go ahead and put in negative 4 here, and then I would take my x value, which is 7, and I would replace it here for the y value. So my new coordinate is going to be negative 4, positive 7. And we can verify that as we rotate it up. We rotate up, rotate up, rotate up, and then as it lines up there, we see that we would move back negative 1, 2, 3, and 4. and then up positive 7, so it indeed is a negative 4. Positive 7 is the new point.